Welcome to SOH, the best office hours because you're part of it. So this is Calculus AB 2023. So you're 2 years younger now. And last problem of the set 6. We're almost done. Bear with me, almost done. If I can, you can, and even better. So let's read about the problem, what it means, what we need to do, and then I will go one by one, but maybe with introduction you will have enough, couple of minutes, and then you can move on. Otherwise, you can go to the problems that you're interested in, and I may say a few more words, okay? So first of all, you can look that the curve here is implicit. We cannot isolate y in terms of x easily, right? So y in terms of x is not something that we can easily do here. It would be possible still because it's a cubic, so there's a solution, but it's not necessary. So the first thing will be to prove this with implicit derivative then, implicit derivative. And we will see what it means in a second, but if you know how to do it and they tell you the result, then you can check it. By the way, this curve here, even though it's not so obvious, it's a curve that may have like maybe vertical or tangent or horizontal lines, but that's if you use, for instance, a graphic calculator like Desmos, you could see how it looks like, okay? But for now, we cannot use it, so we are just going to be kind of blind to what this curve is. The next question, is find the coordinates of a point in which the line tangent to the curve is horizontal, or explain why it does not exist. That's always tricky, because probably you will find that there is a horizontal line, but then the point is, like, if I have a curve like this, I may find a horizontal line maybe here, but it does not necessarily mean that that point maybe is a different height, so it does not belong to the curve. So we will see that, okay? Then the next one is if it's a vertical line. Vertical lines are a bit tricky in the sense that you need that the slope is undefined. It goes kind of close to it, to plus minus infinity, close to it, but basically is that a denominator equals to 0, and well, you have a denominator here, so that's kind of the idea. But again, you always need to check that the point belongs to the curve, so that the point satisfies this equation. It's not just that you have a horizontal line or a vertical line, it's that it also belongs to this equation, okay, to the curve. And then finally, this is a standard problem, so sometimes a little bit long, and they tell you how much it changes in units per second, so very important not to forget this, okay? And then derive how much units per second changes the other coordinate, and they give you a bunch of values and all that. So we will also have to use implicit derivation here, derivatives, to do this, okay? There's an alternative using this formula here, which we could use, but the official solution goes to the implicit derivatives. I will do both. So let's go for it. If you're good with this, great for you. Call me back when you get a 5, and otherwise let's go through each of these problems and see what's more relevant about them, and you may learn something useful for the next one, which is similar, right? So first of all, these things. So as we said before, we're going to use implicit derivatives. And what does this mean? Okay, let's do a quick comparison. So imagine that we have this function f of x equals to x. Well, the derivative is 1. Okay, cool. That's called explicit derivative because you just do it on the go. But imagine that you have a function that instead of that, that's usually also y, right? Imagine that you have that, I don't know, y squared equals x. Well, then the derivative, you can do the following. You can do the chain rule. So you apply the chain rule here, and you do 2y, and then y prime, because this is the unknown, we don't know the derivative, equals 1. So what do you find here? That y prime is y divided by 2y. You also know that in this case, y equals the square root of x. So you could have done that, like explicit derivative on the go. And this is, remember, x 1/2, so this is 1/2, x to the minus 1/2. And if you knew it by memory, you have this. Are these two things equal? Well, you know this, right? So yes, this would be this. So that's what it means to do implicit derivatives. Apply the chain rule, and if you can, you finally substitute y in terms of x. Otherwise, you're happy with the results in terms of y and x, which is what you have here. So let's do that. So let's just get a new page, and let's do it. So what we have is that first, let's copy the function. So we have that 6xy equals 2 plus y cubed, and then let's do the implicit derivative. So it's going to be 6 derivative of x is 1 times 1, 6x y prime, that's the one that we don't know, equals 0 plus 3 y, and then y prime. Now you have to isolate y prime, right? So this is your goal. So you're going to write all the y primes on one hand, on the other. We can also divide by 3 first. So what we have is 2y. This is sometimes it's tricky because if we get one of these coefficients wrong, then we are done, right? So be careful with this. However, they also tells us the solution. So we will compare. But it will save you time if you are careful about it. So sometimes it is better to spend 1 second with the simplification than be too smart and spend 1 minute checking where it went wrong. So we have this, and y squared minus 2x and 2y, that's exactly what we have here. So thank you. We have the solution in this case, they help us. Now whether we have a horizontal line. Well, horizontal line, right? Horizontal, there is no slope. So this means that the slope equals to 0. So if we go back to our super expression that we have here, so we have that the derivative is 2y, y squared minus 2x, okay? That's what we had. And you want this to be 0. So the only way is y equal to 0. But that's not enough, okay? It's never enough. So you have to substitute here and get the value of x, and whether this may work or not. So what happens if y equals to 0? Well, you may say, well, I will find an x. Well, let's see. We have this, and this is just 0, and this is 2 plus 0, so it's impossible. So no. So this curve, despite having a point y equal to 0, where the slope will be 0, there is no x that is associated with that. So no way, no, bad luck. Okay, next time. So let's go for the next one, vertical. Well, probably this is true, right? One is not, the other one is yes, but let's prove it. For vertical, you know, the official solution is a bit interesting. It says just to go denominator equal to 0. Well, our derivative, if you remember, was something like this. So it means just make this equal to 0, right? You can write this in the official solution, denominator equal to 0. Okay, cool. But what's a good way to define that? If you have a vertical line, you know, you have a vertical line, then there is no slope there. I mean, people say infinity. Well, it's like 1 divided by 0. It does not exist. It's not well defined in mathematics. So what you can do is two things. You could define this, that the limit when x tends to this point x to equal to a of the derivative, the limit, not at the value, equals to plus minus infinity. That's one way. But there is another smarter way, and we're super smart. So the other way is that the perpendicular line is horizontal. Horizontal. So basically, the horizontal line, the perpendicular line is going to have a slope of 0. How is the perpendicular line? It's basically, so the slope of the perpendicular line is equal to minus 1 the slope of the line. So it's basically minus 1 divided by y prime. That is all to say that in the end you're going to get to the denominator equal to 0, because minus 1 divided by y prime is going to be minus 1 divided by 2y divided by which gives you minus this thing here divided by 2y. So in the end, if you want this equal to 0, you're going to get the same conclusion. Basically that, let me write it here, but y, this thing is right, equals to 0. However, this is a much better way to justify it, and we want to understand things. So if you have a vertical line, it means that the perpendicular line is horizontal. The perpendicular slope is minus 1 divided by this slope. So I have this expression here, so minus 1 divided by that, I want it to be equal to 0. So you really have a proof, a real proof, not just denominator equal to 0. What's that? Anyway, that's what we need to get the 5 here for college level. But the true college level is this one, right? So anyway, you get this relationship. So you don't really know how much is y, how much is x. It's a relationship between both of them. So again, what we have to do, and this is important, is that we have to find whether this relationship holds on the curve, if it's true here. So how do we do that? Well, you could try to do y equals square root of 2x, right? And back substitute here. That's what the official solution also does. But then we have a y here, a y cube. Why don't we do this? Let's be smarter. Let's isolate x, which is usually not the case. But in this case, it helps us a lot, because it's 6 times x multiplied by y equals this. And this is a very simple equation now, which means this. Oops, okay? So y equal to 1. So we have found that. We have found that y equals to 1. How much is x? Well, it's 1 squared divided by 2. So you got it. Is this true? Yes, because we have used the condition on the curve. For a check, if you want to check, you can substitute that quickly. And 6 times 1/2, because sometimes, we have a typo. 1 equals, the question 2 plus 1 cubed. So we have 3 equals to 3. Yes, as far as we know, 3 equals to 3. That's awesome. And yep, so the point is 1/2, 1. At that point, we have a vertical line. Okay, so this curve may do something like, ooh, and then you have a vertical line here. Okay, now the last question, so yes, the last of the last, is whether, oh wow, we have the particle moving and all that thingy. Okay, so yeah, okay, so there are two ways to solve this problem. The first way is to do implicit derivatives, which I'm going to do now, and is the following: 6 times the derivative of x with respect to time. It's not 1, it's the derivative of x with respect to time, and it is this. Notice the following thing, which is super important, that we have units. So we need to use these units later on, okay? Let's not forget about that. That's one of the things that they always want us to miss. If you see units, use them. If you don't see units, don't worry about them, but otherwise use them. And if you take AB Physics, always use units, by the way. See my videos in physics. So let's do that. So we have this plus, well, let's use the pen better, right? And what we have is this, and then x, and then dy dt. That's exactly what we are trying to find. And then on the other side is going to be this, also dy dt. That is what we are trying to find. Okay, now we have all the values. For instance, the point we have that is 1/2, y equals -2, and then dx divided by dt, as you can see here, is 2/3 of units per second. So don't forget that there is something here that has units. Okay, now let's carefully substitute all these values. So 6 times minus 2/3, no, 2/3, not minus, it's plus, and then multiply by y, -2, here is the minus, 6 times x, 1/2, what we want to find, we don't know it, equals 3 times y squared, so minus this thing here, and then what we want to find. So this gives us the following. Here we can do some simplifications, right? This is number 2, so 4 minus 8, so -8 plus 3 times what we want to find equals 12 times what we want to find. Be careful because that minus went away because of the square. So what we now have here is that the solution before the power is gone, but don't worry, we have enough. It is going to be -8 divided by 9. And super, mega, incredibly important, okay, more important than voting in the elections, is to remember that we have units, okay? Yes, because we have, without units, we don't have a president, okay? So that's it, and that's the result. Now, an alternative way to solve this would be the following, but it's not the official one, but it's correct. So how would we deal with that? Well, do you remember that we have the derivative of this guy? We have the, yes. So we had that this thing was 2y divided by y squared minus 2x. So what you can do is the following. You can have this one equals this. Let's be smart. And then we divide by dt and by dt. So basically, now you can do it. It's 2 times -2, then -2 squared minus 2 times 1/2 multiplied by the 2/3 here. And this is equal to -4 here at the top, right? Well, there will be another term here, but to begin with, 4 minus 1 multiplied by 2/3. And this is another miracle of miracles, but don't forget the units, the same as before. So we did not only get a plus before, but another plus because of this. Okay, so get plus plus, that's your goal. Thank you. See you in the next one. Woo!